Dear everyone, my name is Fuhong. I'm from Nanjing University. My report is Projective Synchronization of Facial Neural Circuits Unannounced Mouse Controller. My report will follow these 5 parts. First, introduction. First of all, neural cortical systems have a wide range of applications in signal transmission, image precision, pattern recognition, biological model, and because the mirror's meter is a full-circuit element that expresses the relationship between magnetic flux and electric charge. It has the characteristics of nonlinearity, nanometer level and memory, and has potential application value in neural networks. Close synchronization control is the key to various fields of close application. From the perspective of synchronization effects, it can be divided into complete synchronization, projection synchronization, lag synchronization, and combined synchronization. Under the influence of the synchronized controller, the motion law of the controller system in different subspaces is different. Therefore, the discontinuous dynamical system theory can be used for the analysis of the chaotic systems. Here, this is a research plan. At the beginning, the myristoyl circuit would be established, and the feedback control of the projective synchronization will be designed. After getting the results, the analytical conditions will be developed with the help of the discontinuous system theory. In the report, synchronization judgment and the control parameters will be performed and studied. With the comparison of numerical simulations and circuitry realizations, synchronization control of myristoyl circuit will be illustrated. Part 2. This is the equivalent circuit of the facial neural circuit. According to the volt-ampere characters of the component and cutoff voltage and current loss, list the equation as follows. With the replacement, we would get the dimensional mathematical model according to the systems. Aiming at the circuit, a new synchronization controller is proposed to realize the projection synchronization between two systems with different amplitudes and to explore the synchronization mechanical systems. Now, this is a master system. This is a slave systems. And the initial conditions will be shown as follows. This is a feedback controller designed, as we all know, from dynamical systems in the absolute coordinate system. The boundaries and the vertex for the controller fit the Hagen-Nagelmann circuit are dependent on time, which is difficult to develop with the analytical conditions. For simplicity, relative coordinate systems are introduced. Z1 equals to Y1 minus P1 X1. Z2 equals to Y2 minus P2 X2. Z3 equals to Y3 minus P3 X3. Then, the corresponding domains, boundaries, edges, and synchronization corner in the relative frame can be expressed as an expression. The diagram shows 8 boundaries in phase space, and the field circuit symbols are the corner for projective synchronization points on the switch corner. With the simulation results, we can figure out when varying parameter K6. It can be seen from that the large number of black and red dots appear in the picture, which means that the system is in the partial synchronization. The vanishing point of synchronization no longer occurs for K6 is more than 7, which means the system is completely synchronized. When K4 belongs to 0.296 4.592. A large number of black and red dots appear in the picture, which indicates that the system is in the partial synchronization. For K4 is more than 4.592, the vanishing point of synchronization no longer occurs, which means the system is completely synchronized. When the three systems meet the relationship that Z1 equals to Z2 equals to Z3 equals to 0 at the same time, the system enters the synchronization area. That is the gray marked part. The 4 area curves are all stable on the 0, 9. The value of the g functions remains positive, and the values of the remaining g functions are always negative. When any one of these relationships is not satisfied, the corresponding system curves will divide from the 0, 9, and the g functions will also cross the 0 point. Based on the principle of the analog circuit, combined with the system equations and the simulation parameters, we can get the multi-sim simulation circuits diagram of the master system. This is the slave system and the feedback controller. Now we will do simulation of the circuit. These results obtained from the operation and the previous parameters simulation results are tracked. and the accuracy of the parameter simulation results can be verified. Due to the limitation of the simulation software, the threshold of some capacitors and amplifiers in the circuit cannot reach the real value in the final results. The voltage has been saturated, resulting in a straight line in the simulation phase diagram. This point will continue to be studied and improved in the subsequent investigations to explore solutions. Now, its conclusion. In this report, design synchronization schemes and control strategies, analyze and discuss two analytical conditions for switching synchronization. Next, study the influence of the control parameters on system synchronization. Complete the circuit design and debugging of chaotic synchronization. That's all for my report. Thank you.